All right, we're going to look at skewed data. And so it's pretty easy. We'll look actually in the center first. So we have three visuals here. We have a histogram, a box plot, and this is just kind of like a bell curve. But nonetheless, when you think about symmetrical, you think about data being exactly the same or close to the same on both sides. So pretty much the graph looks symmetrical. Then we talk about skewness. So left skewed means that the long tail is going to be to the left. So that means that most of your data, so the larger portion of the graph, is actually going to be on the right. And the reason that we call it skewed is because most of the data would be all here on the right side if we wouldn't have had this small portion of data to the left. So skewed left means the longer, like the little tail is to the left. Excuse me, positive or right skewed would mean exactly the opposite. So most of your data is on the left side, but it's skewed to the right because we have just a few data points to the right. So we'll look at a couple of examples. So which data is skewed left? So we want to look for which data has most of it on the right, but the smaller portion is on the left. So option A seems to be pretty symmetrical. Option B seems to have most of the data on the left side, but then we have a few points over here on the right, so it is skewed right. Option C has most of your data here towards the center of the right side, and then it is skewed left because we just have a few points over here to the left. So this one is going to be answer choice C. All right, the next one, this is a dot plot, and it shows the number of TVs owned by each family on a city block. So which of the following statements is true? This one seems to have most of the data over here around like 1, 2, and 3. And then we have a few points over here, like 5 and 6 TVs. That's pretty outrageous to have 5 and 6 TVs in your house. So that is why it's skewed over here. Not most people have 5 and 6 TVs in their house. So we'll read our answer choices. The distribution is skewed to the right without any outliers. So yes, this is skewed to the right. And an outlier would be something like if we had a point way over here, like if somebody had 10 TVs in their house. So that would be an outlier. So it does not seem to have any outliers. So B or A looks pretty good. So we'll look at B. The distribution is skewed to the right with one outlier. We don't have an outlier because we don't have a space or a gap in our data points. So B is out. C says the distribution is skewed left. It is not skewed left. And D also says it is skewed left. So that is incorrect. So A is going to be our answer choice for that. And then last but not least, another example, the histogram below shows the ages of members of a club. And so we're going to look here, see most of our data is over here. The club members are about 40s and up, and we've got a few young members. So this is going to be skewed left because we've only got a few points here on the left. The club is more desirable to an older audience, so the data is skewed to the right. The club is more desirable to an older audience, but it is not skewed right. That is incorrect. B, the club is more desirable to an older audience, so the data is skewed left. That is true because it is skewed left and definitely desirable to the older audience. We'll just look at the rest of the answer choices. C, it is equally desirable to all age groups. That is incorrect. We know over here just by looking at the visual of the graph that obviously the older crowd likes that more. And then D, again, the club is equally desirable to all age groups. That is also incorrect. So our answer choice for this one would be B.